So, hello guys, in my day one of 3 hours coding daily. I had this is my first session. I might stop the stream and do another session where I completed. So, there's why there's a session thingy. So, we will be learning about the thing, but because in the living room, I will close the mic. You will hear some music. Yes, and I'll coding. I'll do coding. But firstly, no here, so I will not stop this mic. Okay, let's do it. Let's do it. And also, yeah, this is how I make my thumbnails because I didn't make any thumbnails. But I just said just make an AI video. That's all. So I made just an AI video. So I'm gonna tell you one thing and that I'm not only in coding, I'm also in other things. I wanted to create a SaaS. I also did know code exactly 1 year ago from this time, but I didn't like a bubble. But I have learned all of the bubble, but now I'm learning it again. Now I feel this whole year has been a waste of time, but it's not because I have started coding, video editing, and lots of other things. And I was not really mature then. I don't think I'm the mature now because every year you get mature, and not the sense of mature of age, but mature about your decisions about things. So in the next year I'll be more mature, more mature. So that's what the thing is. So in these 3 months, I want to make first original goal was 30K, but I think if the mistake that had the big mistake that I have made for this, I have to make it 50K. If I make 50K via SaaS, then I'll be happy. This is just update about other thing. Now we will start about JS that we are going to do. Let me just speak a second. The other thing I will do, I'm also letting this because I want to create my own, but it will take some time. So welcome. So we taught you that I will do here.
An execution context over here and maybe again an invocation, so it
I
can
didn't because I didn't stream the Sunday because it was Sunday. No, I just did
go to any
it.
deep level, right? Function invocation, inside that again function invocation and all these things. So it is very difficult for JavaScript engine to manage, and it does it very beautifully. So let me tell you how it does it. This is the last part of this video.
This is about what if a function invokes another function.
So it handles everything to
I
manage
will
this
also
execution context creation,
bring
deletion, and
my
the control.
mic
It manages a
sometimes.
stack. Okay, so this is known as the call stack. Okay,
Let me just cut time off here. That's you.
this is the beautiful thing in JavaScript. It has its own call stack. So let me show you call stack. So what is a call stack now? Let me show you. So the call stack is like a stack. Okay, so it is a stack, and every time in the bottom of the stack we have our global execution context. That means whenever any JavaScript program is run, this call stack is populated with this global execution context. This whole execution context is pushed inside this stack. Okay, remember this. And when a function is invoked, whenever a function is invoked or a new execution context is created, as in case here in line number 6 we created this execution context, so this execution context is put inside the stack. So let me just denote it by E1, which is the execution context 1. Okay. So this is how it happens. Once we are done with execution this function, we return the ANS. So what happened? Now this E1 is moved out. Okay, so E1 is popped out of the stack, and the control goes back to the global execution context where it left. So the control goes back over here in line number 6. Okay, got it? This is how it works. So this will again literally just pop off even out of the stack. Okay, so now even will be popped off the stack. And then we moved on to line number 7, where the new function was invoked and a new execution context was created, and similarly this e2 will move up to the stack. Okay, this e2 was popped inside the stack, and once the whole function was executed, then e2 will also move out of stack and the control goes back to global execution context, something like this. Okay, this stack call stack is only for managing these execution context. So whenever an execution context is created, it is pushed into the stack, and whenever a execution context is deleted, it will move out of the stack. So that is how the whole control is being managed. This whole execution context creation, deletion, everything is managed by JavaScript. And finally, after this whole thing is executed, the call stack gets empty. Okay, the call stack, the global execution context also like is gone from this call stack, and we are done with our JavaScript program. So that is how the whole code inside the JavaScript is.
I think if this function invokes another function, that means another execution context will be created in this. So it will move up the call stack, and when it will get destroyed, it will give the answer to this one. And then when it will get destroyed, it will get to the global execution system. And when this will be destroyed, the call stack is empty.
Engine is executed. So with this, let me take you to another core concept, which is call stack maintains the order of execution context. Now, I'll tell you one more interesting thing, that call stack is also known by a very fancy names. Okay, there are a lot of fancy names which you will see on web. That is why JavaScript is the most confusing language. Okay, it is most misunderstood language. So call stack is also known as execution context stack. Sometimes it is also known as program stack, control stack, runtime stack, machine stack. All various names are used for this call stack, but it is all the same thing, this beautiful call stack which will just maintain the order of execution of the execution context. I know this is too much to digest in a single video, but thank you for all your patience. Before moving on to the next video, like this video, it gives me a huge motivation, and also keep watching Namaste JavaScript. See you in the next video.
And
You can now learn cybersecurity from IIT professors. With AccuJob's cybersecurity program, you get.
Let me show you some magic. Okay, so we have a variable x which is equal to 7. Okay, and we also have a function which is getName. Got it? So this getName does nothing but just console logs the name of the course. Now
so I will tell you how the execution context or call stacks happen. What happens in this? First, execution context is created. In the memory, there's two parts. The It's called variable thingy, and in the all called the variable thingy. It's called variable, and another thing that I forgot. That's what called the variable thingy, and threads of execution. There are two. In the first phase, mm, it will just load the variable and x and allocate undefined to it, and the function, it will copy the whole function that is inside the function and will copy it. Now in the second phase, it will it will execute and really execute it and give in the numbers. So when the x is equal to 7, so it will put 7 in the undefined x and replace the
must
undefined with x, and it will create another executional context with no, it will not create another execution context. It will just skip the function because no one is invoking the function.
stay JavaScript. Got it? So this is it. Now what we'll do is we'll just try to invoke this function. We
Okay,
invoke
when it
this.
invokes the function, then another execution context is created, and in that it is given the memory allocation. But I don't know console.log. I don't think it's given any memory. It's just I think it's just printed in the execution list.
Function, and we did a console log of x. What do you expect to see here? Now quickly tell me, So you would definitely expect to see that, okay, get name will call this method and will print this on console, and this will print 7. Okay, console log will print 7 on the console, right? So let us run this code. Yup. So as expected. So it was Namaste JavaScript and 7. But now I'll show you something interesting, and it's some magic in JavaScript. Okay, so for that, let us just copy these two, like the function invocation. Let's just cut and paste those two lines really on the top of our program. Okay, so we have pasted these two on the top of the program. Now, before I run this code, let me ask you something. What do you expect to see here? Okay, what will be the output here? So right now, what changed is we are trying to access get name even before we have initialized it. We are trying to access x even before we have put some value in it, right? So what do you expect to see here? In most of the programming languages, okay, this will result out to be error. Okay, this will be a complete error, and you cannot access variables even like before you have initialized it, right? But JavaScript is very different in this case, and here I'll show you some magic. Okay, so if I try to run this code, now you see something interesting, isn't it? So you see Namaste JavaScript is printed. Okay, that means getName was somehow able to access this getName and invoke the function directly, right? And in case of console log x, we got some special value undefined. What is this undefined?
I will tell you why it is called undefined. I will tell you. It's very easy to understand. Before he's telling you, I will tell you. So get name. The function get name. So first we will just walk through the process that is initialized. Okay. First, the memory, the variable thingy phase, the memory allocation phase. It will see get them. It will say okay, nothing to do here because it's used for thread of execution. It's the for that phase. Okay, so console.log and it will see x. It will say okay. Then it will give x undefined here. Okay, and it will give it the this area. Okay, it will just copy paste it to the key value pair. Okay, the key is get name and the pair is name console.long. Now in the where the execution part phase is haptic, the get name will get because of its already what's my hypothesis here is that different expression. There are people here, so that's why I used the way this. But I'll tell you, and it was called undefined because in the memory allocation phase it was given x, but v or console.log is before when the 7 is allocated to x, so undefined will be printed because undefined will be was given to it before 7 because of memory allocation phase, so it will give undefined.
It's weird, right? Let us try to play with it more. Suppose I remove this line completely. Okay, suppose I remove this where x is equals to 7, right? Now what do you expect to see? So let us just run the code. Now we see an error. It says x is not defined. Before it was undefined, now it says not defined. What the heck is going on? Isn't undefined and not defined same thing? No, it's not. Let's cover everything, but let me just get back that statement again. Okay, so this all magic and this all interesting thing is known as hoisting in JavaScript. Okay, so hoisting is a phenomenon in JavaScript by which you can access these variables and functions even before you have initialized it or you have put some value in it. You can access it without any error. Okay, so wherever this where x is there in the program, it does not matter, and you can just access it anywhere in the program. So let me show you one more interesting thing. Okay, you can just access it anywhere in the program. So let me show you one more interesting thing. Okay, so for that, let us just comment these out and let us try to console log.
4 hour stream. Let's do 4 hour stream, man. Or 2 hours. Let's do 4 hour stream and 4 hour stream. Why is Hindi, man? I don't fucking understand any Hindi, man. I don't know why it's Hindi, man. 2:47. Last 60 minutes. I don't know, and keep it this. We will add 1 hour later, okay? Keep it like this. Then you wanna. Let me just write it over here. Add 1 hour after this timer. Or 3 hours is a goal. If I do 4 hours, it's about better. Much better. But I also do have to go editing, coding, and make my sass. But
Our
you know.
get name function. What happens if I remember?
Okay, what is it doing?
Okay, so for that, let us just comment these out and let us try to console log our get name function. What happens if I remember, see, we are not invoking this function, we are just trying to log this get name method. So what do we expect to see in console? So it actually prints the function itself, isn't it? So it prints the function itself. But what if we try to access this even before initializing this function, just like we did for x? Remember, for x we got undefined. What will we get for get name?
We will not get undefined. We will get just the whole function, because in the memory allocation phase, it copies the whole function.
What should we get? Undefined. Let us run and see.
Man, ads. This ad was there just then.
So see, if I run it once again, it again gives us the function. So in case of x, it was giving us undefined, but
If we just, this is a memory key and value pair thing.
in case of, let us just run this. In case of x, it is giving us undefined when we didn't initialize, but in case of get name, it is printing that function. This is very weird thing in JavaScript, and it is only weird because we don't know how things work behind the scenes. Let us go deep and see how everything happened and why the program is behaving the way it is behaving. Okay, remember in the last video we studied that whenever we run a JavaScript program, an execution context is created, and it is created in two phases. The first phase is the memory creation phase. So yes, so the answer lies there only. This whole concept lies there only. Okay, if you have seen my previous video, you might have got an idea also that why these things are happening. But let me tell you again by running each and every line of this code now. Okay, for that, let us just quickly go back to the previous state of the code, like how it was, and then I'll show you something really very interesting. Okay, so remember I told you that even when this whole code in JavaScript starts executing, the memory is allocated to each and every variable and function. The memory is whole code in JavaScript starts executing, the memory is allocated to each and every variable and function. I repeat once again, even before the code starts executing, memory is allocated to this all variables and functions. Remember in the last video I told you, see, if you have not seen that video, I would recommend, highly recommend, see that video. That is really very important video. You know, it is in fact the most important video in this whole series. But for now, let us see that how this memory is allocated. So for that, let us go deep inside the browser. Okay, so when we go to this source, okay, we can see this whole program, right? So even before I am putting a debugger, okay, even before first line is executed, okay, I am putting a debugger right here, okay. Let us see how this whole program behaves. So now see, it got stop in this line itself. So now no code has been executed till now. We are just at the starting point of the first line. Okay, starting point of the first line of our code. And now let's see something really very interesting. This is our memory. Okay, this is the global scope and here is the memory. We will see something really very interesting if we dig down deep. Okay, if we go over here and try to find x, we will find that x has already been allocated memory space even before we have started executing. Okay, so if in the last video I told that in the phase 1 of the memory creation, JavaScript just skims through the program and it will allocate memory to each and every variable and function, isn't it? And it stores a special keyword undefined for these variables. Okay, so even before this code has executed, JavaScript has reserved this memory for x and placed a special placeholder undefined to it, right? We can see that undefined is present over here, right? And similarly, what happens in case of functions? Right, you are right, that whole code is put in. So let us also see whether the code is put in or not. So if we try to find out get name over here, yes, so see, in get name we did not get undefined, but we get a actual copy of a function here. Okay, actual copy of a function even before we are trying to run this code. So now what happens if we just run this program, then all these things are printed on the console. But let us see that phenomena if we put on the top, right? So let us just put these three things on the top and I'll show you how this works, right? So
I told you guys. I told you. I'm smart. I'm smarter, man. Told you guys how it's happening, man. Told you.
again, let us put a debugger on the first line itself, and remember, even before this first line, that is the invocation of getName is executed, we will already have, okay, let me run it again, we will already have these variables and functions in the memory space, right? This x, what will the value of x be? This x will be undefined and this getName will be the function. See, so you see that, that is why, that is the main reason when you try to execute it line by line. See, if I go to the
I
next
want to see something, okay? So when I get a get name, it will create another this what is called executional context, and yeah, because the whole code is copied, you don't really need to get name again. The whole code is copied, really, eh?
line, if I move to the next line,
Not really important.
now if you see the console, you already have these things printed. So over here in the first line, it printed Namaste JavaScript, and in the second line over here console log x, it printed undefined,
Hmm.
and in the third line it printed the whole function code itself, right? So now just let me tell you difference between not defined and undefined, okay? So if I remove this whole line, okay, so now what will happen? Try to
No,
see
depend.
how
It will give
JavaScript
an
works.
error because there's no variable. But before it just had a variable. There was a value called undefined that is given to a thing before in the memory allocation phase for the thread of for the execution phase. Yeah?
So as soon as it goes to the first line, okay, so let me
So
put a debugger again. Okay, so
oh
as
no, man! What the hell, man? What a hell, man? What happened?
soon as it goes to the first line, now we have not reserved the memory for x, we just have reserved memory for get name, right? So in this case, when the code goes over here, so it tries to access x and this x is not present because we have removed that, right? So now x is not present and there is no value for x, so that means now JavaScript will throw an error and it will say that reference x is not defined. That means x was not present in the
Okay.
memory, so that means x is nowhere initialized in the program and you are trying to access the value of x. Okay, so that is how JavaScript works and that is why it behaves the way it behaves. It was interesting, isn't it? So let us just see one more important thing. Okay, let us see one more interesting thing. Suppose instead of this we have get name as the arrow function. Okay, suppose we had get name as the arrow function.
Man, I know something
Okay,
about arrow function, but
so this is how we write the arrow function, right? So now what do you expect to see in the browser console?
undefined.
Give a guess. Let me just run it and show it to you. It says that getName is not a function, right? So let us try to see why it says that. So when you are executing this piece of code, when the getName is an arrow function, so it behaves just like another variable. Okay, now this getName does not behave like a function, but it behaves like a variable. So what it will do is, even before we execute this whole code, so now when in the memory allocation phase of the execution context, it will allocate, just like it allocates undefined to x, it also allocates undefined to the get name. Okay, so let us see in the global space now, global memory space. Here if we see and try to find out get name, see we got undefined. So before, if when we wrote over here function like this, like function get name, let me show you here once.
Or like this.
Function get name 2. Okay, so if we use something like this, okay, so it reserves, let me save and run for you. So it will put get name 2. See, the getName2 will be the function itself if you write it in this syntax, and if you write it as an arrow function, it will be undefined. Make sense now? This time getName behaves just like another variable. Okay, and there is one more interesting part. So there is one more way to declare a function. Wait, I'll show you. So you can also create a function like this, where getName is equals to using this syntax. Okay, so what happens in this case? So
It also
in this
sends.
case also, if you save and run and see, it behaves just like a variable. Okay, so it behaves just like a variable. So if you see the space now,
Oh, by the way, pro tip, start your free trial on the annual plan because it's the only way to get access.
so see, get name 2 is undefined again, and get name is also undefined. So in this case, and in this case, it just behaves like another variable and it will allocate the memory with a placeholder undefined. Okay, and only in case of proper function declarations like this, get name, it will copy the whole code. Okay, so in this case, if you run again and see, if you run again and just refresh the page and try to see, so while reserving the memory for get name, see, it gets you the whole function. So this is how it works, and you can even access these variables and method even before it is actually initialized in your code. So that is all about hoisting. Okay, so next time in
I mean, like, you don't really need to. I know, I'm thinking, like, you don't really need to declare a function before you invoke it because it's already in a memory space. So it doesn't, like, change. Even if you just put it first, it will just skim through it because no one is invoking the function. So I think there's nothing, like, bad. You can invoke it, like, really.
the interview, if somebody, the interviewer asks you that what is hoisting, so don't just say that JavaScript kind of moves that code to the top of the file and whatnot. So that is not the case. The proper answer lies here. Okay, you have to explain this thing. This shows that you know JavaScript in depth. Okay, the execution context creation phase properly. That there lies the answer. Okay, but now when we are already there in code, let me show you something really very important. Just give me 2 more minutes. Okay, I'll just finish it very quickly. It is very nice concept. So remember, I covered the theory of call stack in the last video. Now I'll show you the demo. We actually are in code, so it will be easy for me. Okay, just wait for 2 minutes. Okay, so let me just tweak the code a little. Let's just get back to where we were. Okay, so over here. So let me.
Yeah, what I was talking about is I don't think it's really makes makes any difference to just try initiate invoke it before. I don't think that.
Show you that how that execution context and call stack works,
Yes.
right? I'll show you the demo. Before, in the next previous video, I showed you the theory portion, right? This is interesting part. So let me just do it quickly. Oh my god. Namaste JavaScript. So I'll properly show you that how code is executing. Okay, so let me just put a debugger on the first line again. So remember, in the last video I told you that whenever JavaScript code is run, what happens? A global execution context is created, right? So
Yes.
let us see how does that global execution context look like. So let us run the code. So I have put a debugger over here. So the global execution context must have created somewhere, right? So yes, the global execution context was created and it has put in this call stack. So see this. See this anonymous written, right? This is the global execution context, and the control is on the line number 3 of index.js right now here. There it is. Now I'll tell you something more important. Remember, as we move ahead in the code, I have put a debugger over here. So as soon as we run this function, as soon as we invoke this getName function, what happens? Remember from the last video?
Yes. Yes. It will invoke this function, and this function will make another executional context, and all the process will happen. But the power will be given to it, and when the function is executed, then then it will delete itself, and it will be given to the global context, the global this context. Okay.
A brand new execution context is created, and what happens? That execution context is pushed inside the call stack. Remember I told you? So let us put a debugger and check that also. Now it will go to this function and go inside the function, right? I have put a debugger over here. So let's just run it. So see, now the control went to line number 5. Okay, so now see, something really very interesting happened, right? So execution context of getName was created and it was pushed onto the call stack. So this is the call stack. Remember, this is the global execution context which is lying in the bottom of the call stack. Okay, and on top of it, right now we are at line number 5. I have put a debugger over here. So here lies the control of the program in the getName in line number 5. Okay, this is the interesting part. So now what happens once you finish executing this function? Remember what I told you? Now that execution context will be deleted and it will be popped off the stack, right?
Yes.
So if I put a debugger over here and the control will move to line number 9. So now if I'll run, so what will happen is whoosh, the execution context will be deleted and it will be removed from the call stack. So let us run and see. See, now it vanished, right? So now the control again went on to line number 9, okay, of this anonymous, which is the global execution context. So that is how the whole small this call stack works. I wanted to show you the demo because I covered the theory in the last video, but I like demo was not covered, right? So and once we finish executing everything in the program, see, the call stack is empty now. So this is what I was trying to explain a lot in the theory in the last video. That was really very important video. If you have not seen that, definitely I would suggest you to see that. And this was the demo of that whole thing. So this is how everything is working behind the scenes inside the JavaScript engine. and JavaScript manages all this using the call stack, execution context, and all this fun stuff. And it is created in creation phase, and then the code execution phase, thread of execution. All these fancy things are happening inside this browser itself. Interesting, isn't it? So that's all in this video. In the next video, we'll be covering the heart of JavaScript, which is the functions. I'll be talking a lot more about the functions because functions are very important piece in JavaScript itself. They are very different than other programming languages. But before moving on to that video, you have to do two things. First is to like this video. It gives me a huge motivation. And second is to comment down whether you're feeling excited or not. How was the video? Comment it down. I would love to read your answers. See you in the next video, and thank you for watching Namaste JavaScript.
So yeah, so let's see some things. Namaste. Yeah, I was already taught this year. Namaste.
Building a RAG application is so easy, and I'm going to show you how to do it
Namaste.
using AstroDB,
That was fun.
LangChain,
Say
and JavaScript
namaste.
with just under 50 lines of code.
So namaste.
So
Namaste.
let us now explore. So let us now explore a little bit more about function invocation and variable environment. Okay. So for that, let us take a function.
What
Okay.
is
So let us now explore a little bit more about function invocation and variable environment. Okay. So for that, let us take a function. Okay. Function A, and in this function we have a variable x.
yes,
Okay,
yes,
let us take a function.
yes.
Okay, function A, and in this function we have a variable x. Okay, where x, and let us assign 10 to it.
Yes.
Okay, and what we'll do is we'll also do a console log of the same
I
variable.
think the console log happens in the execution phase.
Okay, now what I am trying to showcase you over here is that if suppose we have one more function b and we use the same variable name. Okay, suppose if I use the same variable name,
It will just change. I suppose it will change the variable x value or give an error bit of both. I think so. No, I think it will change because where is a global it's a global variable. It works outside the function. You should use let because it's only used in the block, which I just teach you. Block, yeah, see, it's only used in the block. It is only in the block, so it's not a global function. Yeah,
over here where x is equals to, this time give it a some other
valid.
value, so let's say 100, and let us log this over here also. Okay,
If someone is watching, please like and comment something new because it will give me some motivation like he, because I have not seen anyone comment unless one guy was have written a code and I was really motivated by him. Please, if you are watching this, please like and comment, please. Just comment, please.
what I am trying to show how function invocation behaves behind the scenes. Okay, let
How?
us see that. For that, we'll take these two functions and let how function invocation behaves behind the scenes. Okay, let us see that. For that, we'll take these two functions and let us introduce something in the global space also. Okay, so suppose we had the same variable name
Uh,
where x is equals to let's give it 1. Okay, 1 at the top of the program. Okay, and then after putting this 1 inside x, we invoke these two functions. Okay, suppose if I invoke these two functions, and remember from the last video, we can do this, like we can invoke these functions before even
Okay, let me think what will happen. Okay, first is
initializing
what
them,
is
just because of hoisting. Remember from the last video we told, now what we are trying to do is this var x, we
okay, let me just think. If if it's invoking x first is colon 1, then it's invoking a. Huh? No, it's invoking a. Then where x is equal to 10, then it will become 10. It will console log 10. It should get 10 and 100.
we are putting 1 over here, and then we are invoking these functions. Okay, that means this code will be executed and these lines also will run. Okay, so what I'm trying to say is that if we have same variable name all over there, so how our program behaves, how JavaScript handles this
We'll say 10, 100, respectively. That's what I think in the function invocation.
scenario. So we'll be talking and seeing this in detail, what happens behind the scenes. Okay, and after invoking these two functions, let us log this x once again, and let's see what output
It will give 100.
we get. Cool. So now we are here with the program. So now let's see the output, and then we will see how this whole program works behind the scenes, line by line. That would be really very interesting. So whatever we learn in this video will be helpful for learning scope, for learning closures and everything. Okay, so we are moving slowly towards that phase. Okay, so let us see first of all what the output will be. Okay, so here is our browser. So let me just save this program and see. We got the output 10, 100 and 1. So let us go dive deep into that and see that how that program was executed and this output came up. So behind the scenes, when we run this program, so whenever JavaScript runs any program, a global execution context is created, right? So let us create this global execution context. So here is our global execution context. So as you might remember, it will have two components again, right? The memory component and the code component, right? So this memory space is also known as variable environment. Remember? Okay, so this is the variable environment, and now even before executing a single line of
Now
code,
I know it's
okay,
called variable
and
environment.
now
Guys,
now even before executing a single line of code, okay, memory will be allocated in the first phase, right? So in the
yes.
first phase, let us allocate memory and see how this works behind the scenes. So first of all, we will be allocating memory to these x and this function a and this function b. Remember, as we told in the previous videos?
Yes.
Okay, so let us allocate memory. So memory will be allocated to x, memory will be allocated to a, and memory will be allocated to b function.
Yes.
The more nonsense the AIs pick up, the more mistakes they start making. And the more time we'll get to eat 5-star and do nothing. Join us on makeAImediocreagain.com.
Okay, and what will be stored in this variables? Come on, quickly tell me. Okay, so
So,
x
undefined, and this will copy the whole code.
will store. Yes, you are right, undefined. Okay, in the first phase, undefined, and a and b will point to the function code. Okay, these a and b will be pointing to the exact function code, this function code, right? They will be pointing to this exact full function code. They won't be storing undefined. Okay, so that will happen. And remember, in the last video we also discussed a little more about call stack. Remember call stack? What was it? So let us create a call stack for
Also,
ourselves now.
so first, it will just use a global execution context.
So let's create this
First,
call stack.
it will
So this
copy
call
copy.
stack is a stack where all these global execution contexts are kept, right? So what will happen? as in when we created this whole global execution context, this will be pushed inside this stack. So let us
Yes.
just put it. So here is our global execution context right at the bottom of our stack. Make sense now? So now let us see what will happen. Now the actual time comes when the code will be executed. So when we run this first line where x is equals to 1, okay, so when we run this first line where x is equals to 1, so what will happen is this 1 will replace undefined over here. Okay, so now let us just replace undefined over
Yes.
here. Okay, so now let us just remove this undefined and put in 1 over here in its place. So let us put 1. So here is our 1 over here. Now the x becomes 1. Now the code moves from this line to this line. So now comes the interesting part of the video. Okay, a function is invoked.
So it will get another execution context.
Function is invoked. Let's see what happens. So whenever this function a is invoked, this function is invoked, now a execution context is created. This execution context is very much limited to this function. Okay, this is what I am trying to make you understand. Okay, so a execution context is created. Here let us create an execution context. So this execution context again have two things, right? What are these two things? Memory
Memory,
and the
which is
code.
like variable environment and threads of execution.
Got it? Now it will again go through two phases. Remember two phases?
Yes.
First is the
Memory allocation and that's the execution phase.
memory allocation phase. So this execution context is limited to this piece of code, right? So memory will be allocated to all the variables and functions inside this piece of code.
But
Okay, there
what I have
are no
done was
parameters
where is a global container? Oh, I don't
to all the variables and functions inside this piece of code. Okay, there are no parameters, so no issues. There are no functions, no issues, but there is a variable x, right? And it has the same name as this. Okay, but what I'm trying to tell you is that this x will have a separate new copy inside this variable environment. Okay,
do have no effect.
not a copy, I would say it's a separate variable altogether. This execution context is like independent of everything else. It's like a mini environment, sort of a mini place environment where this small function code is executed. That's it. Okay, so let us try to allocate memory to x now. So inside this small execution context of a, x will be allocated. Okay, x will be
Undefined.
allocated memory and undefined will be stored over here. Remember, undefined will be stored. One more thing to notice, okay, I forgot to tell you, as soon as this function is invoked, so as soon as this execution context is created, it is pushed in the call stack.
Yes.
Okay, this is the important thing. Remember, I'll show you the whole complete picture now. So this execution context was pushed into the stack. Let us push it. Okay, let us push it, and now we have a inside this call stack again. Okay, and the control is over here. Okay, a, and the control is at line number 7.
Yes. Yes.
Right now is over here. Okay, a, and the control is at line number 7 right now. Okay, and when this function was invoked, the control in the global execution stack was at line number 2. Remember?
Yes.
So the control was here, like the code was running this. So global execution context was at 2,
Mm.
and now we are at 7, line number 7, this line. Okay, so once we execute this line, let us execute this line where x is equals to 10. So this where x is equals to 10 is now executed. So once we execute this, 10 will replace undefined.
Yes.
Okay, so let us now replace this.
Hi, I'm Jared, and I use Bittrex 24 to manage projects because it gives me choice. Oh, a new project.
So after this line, we move to line number 8 now. Okay, so line number 8 is the console log of x.
Yes.
So what happens when you do a console log? Let us create a small console for us also. So this is our console. Let us see. Let us say this is our console. So when you do a console log of x over here, console log of x, so now JavaScript engine will look for the value of x in the local memory space.
Yes.
Okay, so when I say local memory space, that means it is very much limited to that particular execution context. So
Yeah,
this is execution
because it's in the executional phase. It is in this executional context, and it cannot move out of this because it's in a executional context. This executional context. That is why, and it will just use it's this way.
context. Local memory is this, and this value of x, JavaScript engine will search for x inside this local memory. It finds 10 and it prints it on the console. Got it my point?
Yes.
So it finds this x value in the local memory, takes that and prints it to console. Okay, that's how this code is executed, and the console will now have 10 in it. Okay, now 10 will be printed in the console, logged in the console. Okay, so what happens now? We are done with our code of this function. Remember, now we have finished executing. So what happens if we have finished executing? Now important thing, right? Remember I
It
told you
will
in the
delete.
previous
It will
videos,
delete
this
it.
whole execution context is deleted. It's vanished. The memory is gone, this whole execution context is gone, and this call stack is also gone. Like this whole functions will be removed from the call stack also. Let's pop off now. So let us try to pop this out from the call stack. Okay, let me remove it. So now this function is popped out of the call stack, gone, finished. Now the control goes back to global execution context line number 2 where we left. Okay, we left at this point, right? So now this a function has been executed. So now the control moves to line number 3. Okay, so let us move the control to line number 3 over here. So now again comes an important part. Again a function is executed. So let us just quickly do it. Bear with me patiently, but you'll learn things. Okay, so what will happen is now we move to line number 3b. Okay, now we invoke a function. Again a brand new execution context is created, right? Let us create an execution context. So we created this execution context, and it will again have two components, memory and code. It will again have two phases. First phase, remember what was it? X will be allotted undefined to it. Let us put in undefined. Okay, and with this we will now execute the code. Okay, so when we execute this piece of code, so x is equals to 100, so 100 will replace over here. Okay, let us do that. So it will run where x is equals to 100. So this 100 will replace undefined over here. So let us just replace it quickly. So once we replace this 100 with x, now we will execute another line, which is the console log of x. Console log of x. Okay, so now JavaScript will try to find out this value of x inside the local memory. It will find x over here as 100. So it will print it onto console. Okay, so
Yes.
let us log this thing onto console. So now 100 will be over here. Okay, so this 100 will go over here. Now what happens? Again we have finished executing this whole code. Okay, so once we are finished executing, and this whole execution context will be popped off the stack also. Oh shit, we forgot to put it in the call stack in first place. Okay, but as soon as this execution context was created, right, it was pushed into the stack. Let us put it now what's there, right? So this was here, right? This was present here. Now what will happen once the whole code is executed? So this will pop off the stack. Okay, it will come out of the stack and it's gone. It's completely deleted. Even this memory space, everything is deleted. Okay, so let us just remove this out of the stack now. So let us remove this, gone. Okay, now the control goes back to global execution context line number 3. Okay, this line has finished executing and it will move to line number 4. So now it will execute line number 4, console log of x over here. Okay, so let me first remove all these things, right? These execution context and everything is not here, right? So let me just remove and erase it quickly. to make things clear. So now we will remove this all thing, and now what will happen is this line number 4 will be executed. Okay, so now JavaScript engine will execute this line number x. Okay, so when it executes this line number 4 over here, now it will look for x inside the local space, so the local memory of this particular execution context.
Yes.
Okay, so over here the value of x is
One.
1. Okay, this one. So this x1 value will be printed in the console
Yeah.
when we execute this line. So what will happen? The JavaScript will print 1 in the console.
And
Okay, so 1 will
and then this will be deleted. Whole thing is
be
deleted.
printed in the console now. And we are finished executing our line number 4 also in the global execution context. Now JavaScript engine moves to the next line. It sees that there is nothing more to execute in any of the lines now. Okay, so
Yeah, because function is not itself used, but or when an invocation is happened. Okay, then it will do something
in
else.
the remaining program there is nothing more to execute, isn't it? So now once whole code has been executed, now this whole execution context will also be deleted. Everything will be deleted. Even the call stack global execution context will be popped out, and nothing will be left. So let us just remove everything, right? So this whole thing is like removed. Okay, this whole thing is gone now, and even from the call stack, this global execution context is gone. So we are now left with nothing with us. So that is how this whole program is executed. So this was all the visual representation, right, with the help of diagrams. Now let us just see all these amazing things happening inside the browser also. I am telling you, this will be real fun. Keep on watching it. Okay, so here is our program and we got this output right in the browser. But let us now see that what happens behind the scenes inside the code, right? So for that, let us put the debugger again. So remember how this whole code executes? So let us put a debugger over here. Now what will happen once you run the code? Remember the first step, global execution context will be created and pushed onto the stack. So this is the call stack here. Listen to this very carefully. This is the call stack here.
Yes.
When we run our program, uh, a global execution context will be pushed onto the call stack.
Yes.
Okay, so let us refresh the page and see. Yup, see this we got right. Global execution context is
Yes.
now created and it is over here. The control is on line number 1. Okay,
Yes.
ChipIgnite from eFabless, a hands-on chip design and fabrication platform for engineering students. ChipIgnite is a complete solution providing access to open source EDA.
now what we'll again see, there must be some memory allocated, isn't it?
Yes.
What should happen in the first
Undefined.
phase? X, A, B should be allocated memory, isn't
Yes.
it? So there
Yes. It
must be
will be allocated memory, and A B, that's their function. The whole code will copy that, give it value. The key will be A, and the other variable will hold undefined.
some memory. So here in the scope we have this memory, right? We got all these memory allocated. So we have this function A, C, we have this function B, and what will be there in X? Remember what will be there? That special keyword we used to see.
Undefined.
Yes, so X will have undefined in it. So here is undefined in it. So now the code will start executing. So once we execute this line number 1 and move to line number 2, okay, let me remove this breakpoint, line number 2. So let us play this. Now the first line is executed. Now see, the value of X must have been replaced with undefined, would have been replaced by 1.
Yes.
So let us go in and say, so over here X would have been, where is, yes, so X now became 1.
Yes.
Okay, as expected. Now what will happen as soon as we run this a function? Now once the function is invoked, a execution context is created and pushed onto the call stack. Remember?
Yes.
So now watch this space carefully. Okay, when we create this call stack will push a in it. Okay, let me put a debugger over here to visualize it properly. So now I'm running the code. Okay, just see, a new execution context will be created and it will be here in the call stack. Okay, I am pressing the play button. Okay, yup,
Yes.
see, Now we got this A here, right? Interesting, isn't it? So now we have this A here and the control moves to line number 7, right? Over here. So this was the global execution context and this was A. And now see an interesting thing also. So it has its own memory space and this A has its own memory space as well. So it has its own memory space and this A has its own memory space as expected. And see, here are two things, right? We have this global memory also and we have this local memory also, remember? And as we said that in the local memory of that execution context we have this x as undefined also because the code hasn't started executing, right? We have put a debugger over here. So this is interesting thing. So X will have undefined in it. So here is undefined in it. So now the code will start executing. So once we execute this line number 1 and move to line number 2, okay, let me remove this breakpoint, line number 2. So let us play this. Now
Yes.
the first line is executed. Now see, the value of X must
Will
have
be
been
1.
replaced with
And guys, it was lagging very much.
undefined would have been replaced by 1. So let us go in and say, so over here x would have been, where is, yes, so x now became 1. Okay, as expected. Now what will happen as soon as we run this a function? Now once the function is invoked, a execution context is created and pushed onto the call stack. Remember, a execution context is created and pushed onto the call stack. Remember?
Yes, yes.
So now watch this space carefully, okay? When we create this call stack will push A in it, okay? Let me put a debugger over here to visualize it properly. So now I'm running the code, okay? Just see, a new execution context will be created and it will be here in the call stack, okay? I am pressing the play button, okay? Yup. See, now we got this A here, right? Interesting, isn't it? So now we have this A here and the control moves to line number 7, right? Over here. So this was the global execution context and this was A. And now see an interesting thing also. So it has its own memory space and this A has its own memory space as expected. And see, here are two things, right? We have this global memory also and we have this local memory also, remember? And as we said that in the local memory of that execution context we have this x as undefined
Yes.
also because the code hasn't started executing, right? We have put a debugger over here. So this is interesting thing, right? And you must be wondering that what is this thing, right? Don't worry, we will be having a separate video altogether covering this concept also, but for now just understand that in the local memory, so we have just x is equals to undefined in the first phase, okay?
Yes.
So
Sorry I'm late.
It's all good. We've been taking mornings off. The team's been working so fast now that we had Jira Service Management.
Oh, fun.
let us go executing the next line again. So what will happen? Now let us run. So x is now
10.
moved and this undefined is replaced by 10 now. Interesting, isn't it?
Yes.
Now what will happen? Now let us execute this. So once this console log will be executed, the control will go back to line number 3, isn't it?
Yes.
So let us put a debugger and like run this piece of code also. So we ran this piece of code and
The call,
see this in the
it just popped out of the call stack.
console. We got 10, right? So the 10
Okay,
was
it's out of
printed
the call stack.
and interesting thing happened, right? The call stack is now moved to global execution context now. That execution context of A was popped off this call stack. This also happened, right? Now when now we move to line number 3, right? So we will invoke the B function again. Let's quickly do that again. Let me put a debugger over here also and we'll show you what will happen. A new execution context will be created and pushed into the stack. See, now the B is in the call stack. It will again have its
But
local
now
memory.
I remember it is stored in the memory, and it will go to the, and when the execution cortex will create it, it will go to that particular line.
X over here is undefined. Now when we run this run this line, so 100 will replace undefined. See, let me run that again.
And why he, when he's in console.log, it will change, because in the memory allocation phase there is a no use of console.log, so console.log will be only executed in the execution phase. At the execution phase, X is already given 100.
Again, see, now 100 came over here in X, right? And console log of X will print it and move to line number 4. So now
Guys, I will just stop the voice because someone is coming. So bye. I will just write in the talk.
carefully watch watch and think. Okay, so once this console log of x is printed and we are done with the function, what will happen is this b will be popped off the stack. I'll play and you quickly see that. Okay, see, the b was moved out of call stack, right? And in the console, see, 100 is printed, isn't it? So now we will move to line number 4, and once we execute this line, what will happen? Our whole program will be finished and even the global execution context moves out of the call stack. Okay, so let us just play this. Yep, see, now the call stack is empty and we are done executing everything, and console log 1 is printed, right? This console log 1 is printed. So that's how this whole code is run, and that is how this whole and console execution context moves out of the call stack. Okay, so let us just play this. Yep, see, now the call stack is empty and we are done executing everything, and console log 1 is printed, right? This console log 1 is printed. So that's how this whole code is run, and that is how this whole every execution context maintains its own separate space. Okay, so even if that execution context is created by a function, or it is the global execution context, or any other execution context, they will have their own memory space, they will have their own virtual kind of an environment where they are running separately, independent of each other. That is what the motive of this whole video was, to explain you this small thing. Okay, so in the next video we'll see the shortest JavaScript program. Do you know what is the shortest JavaScript program? We'll see in the next video, so watch that video. But before moving on to that video, give this video a thumbs up and keep watching Namaste JavaScript. Do you know what's the shortest JavaScript program? Here it is, the empty file. I know you must be thinking that, Akshay, are you kidding me? But no, I am not. You know, even though this file is empty, there is nothing to execute, still JavaScript engine is doing a lot of things behind the scenes. So let us now see what happens behind the scenes when you run this shortest JavaScript program, that is the empty file. Okay, so let's go to the source and put a debugger over here. You know, JavaScript engine will still do its work. What will happen is, suppose I execute, let me run this JavaScript program. What happened? A global execution context is created, and JavaScript engine still creates the global execution context and also sets up the memory space. Okay, though there is nothing to set up, but still it does its job. Okay, and it also does something interesting. So JavaScript engine also creates something known as window. Okay, I'll show you. So if you go in the console and try to write window, you'll get something. What is this? What is this window? So we didn't do that. We didn't put any window inside our code. How did it come up? And if you see clearly, this is like a big object with a lot of functions and methods, right? These functions and variables are created by JavaScript engine, you know, and into the global space. You can access all these variables and functions anywhere in your JavaScript program. This functionality is given us by JavaScript engine. Okay. And just like this window, JavaScript engine also creates a this keyword. This window create function we didn't put any window inside our code. How did it come up? And if you see clearly, this is like a big object with a lot of functions and methods, right? These functions and variables are created by JavaScript engine, and into the global space. You can access all these variables and functions anywhere in your JavaScript program. This functionality is given us by JavaScript engine. Okay. And just like this window, JavaScript engine also creates a this keyword. Okay. A this for us. So if we do this, okay. And just like this window, it access script, right? These functions and variables are created by JavaScript engine, and into the global space. You can access all these variables and functions. It also does something interesting. So JavaScript engine also creates something known as window. Okay, I'll show you. So if you go in the console and try to write window, you'll get something. What is this? What is this window? So we didn't do that. We didn't put any window inside our code. How did it come up? And if you see clearly, this is like a big object with a lot of functions and methods, right? These functions and variables are created by JavaScript engine, and into the global space. You can access all engine, and into the global space. You can access all these variables and functions anywhere in your JavaScript program. This functionality is given us by JavaScript engine. Okay. And just like this window, JavaScript engine also creates a this keyword. Okay. A this for us. So if we do this, we also get something, right? And in the global level, at the global level, this points to the window object. But wait, at the global level, anywhere in your JavaScript program, this functionality is given